Wouldn't you like to impress guests at your next party by explaining the difference between host and bridge networking? This week on Mobycast, Jon and Chris conclude their 3-part series on serverless containers with AWS Fargate. We wrap our heads around container networking and its various networking modes, with particular emphasis on task networking, aka AWS VPC mode. We finish by pulling together everything we learned over these 3 episodes to walk step by step through the migration of a container from EC2 to Fargate. After this episode, you'll be the life of the party. Welcome to Mobycast, a show about the techniques and technologies used by the best cloud-native software teams. Each week, your hosts Jon Christensen and Chris Hickman pick a software concept and dive deep to figure it out.
Welcome, Chris. It's another episode of Mobycast.
Hey, Jon. It's good to be back.
Hey, good to have you back. Here we go. We're going to talk a little bit more today about ECS. This is episode 3 on ECS, isn't it?
It is.
Yep.
That was not planned, but turns out...
No.
I mean, there's a lot here, and truth is we could probably do a 12-part mini-series workshop all about ECS and lots of just really interesting, good stuff with it.
I mean, let's be honest. We could have like a whole podcast on ECS.
We could.
You totally could. You could go through all the features and all the changes, and you could talk to different people about how they're using ECS, problems they're having with ECS. You could interview AWS developers about ECS. You could do a whole-on ECS podcast.
Mm-hmm. Absolutely.
We're not going to do that, though. We'll try to keep it to this last episode. Or is it this or this and 2 more? Or this and 4 more?
We're going to wrap up.
Okay.
This is a 3-part series on serverless containers with Fargate.
Mm-hmm.
We're also taking some detours here to some of the really important core key aspects of ECS, like identity and access management. We're going to be talking about container networking. We've talked a little bit about auto scaling and how you scale these things up and down, right? So we're touching on various key aspects of ECS that you kind of need to know on a practical basis as we discuss it in the context of how do I go from an EC2 launch type to a Fargate launch type and go to this serverless model for running my containers as opposed to managing the EC2s myself.
And just in case somebody happens to stumble onto this series on part 3 and hasn't listened to the other 2 parts, one of the questions I asked in part 1, I think it bears asking again, and those people that stumble in can kind of hear the answer to this and then decide whether to start on part 1. So the question is, if you're not an ECS user, is there any value here, Chris?
Yeah, I mean, the additional context that we're going to be talking about, the different areas and topics of just stuff you need to know when running containers in production. So there's quite a bit of overlap here that applies to kind of whatever orchestration system you're using. I mean, that said, there is a lot that's AWS specific. Mm-hmm. But again, when we talk about container networking and just we're going to get into what the bridge network mode is, and that kind of applies wherever you're running Docker, whether it's inside ECS or Kubernetes or on your own or however else it is. So understanding kind of identity and access management too is the implementation of it is specific to AWS, but the concepts apply across the board, right?
Yeah, I can imagine it'd be useful for almost anyone too. Like even if you're in Azure and you're on Kubernetes or GCP on Kubernetes, I kind of wish there was somebody doing exactly what we were doing on those so that I could listen to it and just kind of find out what I don't know about those other cloud engines and sort of do some comparison and learn from that. So yeah, I can imagine people that are on those other clouds might get something out of this too.
Yep, absolutely.
Cool. All right. So again, no pleasantries this week. No weather discussion. No biking discussion. We're just going to jump right in because last week at the end we had to take a listener poll and decide whether we were going to extend this into 3 episodes. And listeners overwhelmingly said yes. Let's do it. So here we are, episode 3. Can we jump in, Chris? Help us out.
The responses were deafening.
Yes.
So yeah, let's jump in. So just real quick recap. Last week we talked about, we started going through this process of, okay, how do you go from the EC2 launch type to the Fargate launch type with the container? And we said, hey, as part of that, let's kind of dive deep into 2 really important areas of ECS that are kind of going to help inform us as we do that migration. And one is identity and access management with ECS. And the various roles that are required by ECS itself as a service and other services, and then also more important, just as important, or very important from a security posture, is to use task-based IAM roles for our containers. So don't share a single identity for all containers running on our instances. Instead, we should narrow it down so that each specific service has an identity associated with it that has the minimal permissions that it needs to do whatever it is it needs to do. And you do that on a service-by-service basis. So that was last week. Today, we're going to dive deep into container networking and kind of understand, just at least at the ECS level, like what's important there and what we need to know. And we're definitely going to be touching on some things that are probably not very common, that maybe not a lot of people know about. And so it should be interesting. And then after that, we will wrap up by now going through these practical steps of, okay, I have an existing container. It's on my EC2 launch type. And now when I get it running on the Fargate launch type, what exactly do I have to do? Like how hard is that? What are the steps? And so we're just going to walk through the steps. That should be fun as well.
Cool.
All right. So with that, why don't we dive right into container networking? So Docker, whenever you run a container, you're going to be specifying a networking mode for that container to use, right? And so there's lots of different options here. The default networking mode is bridge, but there's other options as well. So with ECS, we're going to specify that networking mode as part of our task definition. With ECS, we have 4 different values for this networking mode, right? 4 different types. So one is none, right? So this is pretty straightforward.
My favorite,
right?
personal favorite.
Yeah, really straightforward, pretty easy, right? There is no network, right? So we have 100% coverage on that now, right? We can nail that. That's on an exam question. We got it. We know everything we need to know about networking.
Yes.
Right? Good. So the next one is bridge. And so we kind of talked about that. That's the default mode. And then 2 other ones, host and then AWS VPC. And so we touched on AWS VPC last episode, and we're going to dive even deeper in it today. But let's talk about host first. And so what the host networking mode does is it bypasses Docker's built-in virtual networking and instead just maps straight from the container to the host that we're running on. So there's no proxy between us, and there's no difference between like container port versus host port, right? It's just they're one and the same. It's basically just the host port.
Okay.
And so some implications of this, right, is that you're going to have port conflicts if you're not careful. You can't run multiple instantiations of the same task on a single instance when you have these with the port mappings, right? So if I have a container that says that I want to listen on port 80, you're only going to be able to spin up one of those on that particular instance, right? Because it's now using the host port 80. So no one, and not only that, like not just additional copies of that particular container, but any other container that wants to listen to port 80. And so if you wanted to use host mode and you're running multiple containers and different apps and services and whatnot, so it's going to get pretty messy pretty quickly, where you're going to have to go and keep track of these mappings, right? And know, okay, hey, for this particular app, I want him to be listening on port 8080, and then this other one's not going to listen on port 8081, and then you have to manage all this stuff yourself manually, and you can set up listeners on your load balancers to forward appropriately to those ports, but overall kind of messy, but pretty straightforward from a networking model, right? There's just one networking system there. There's no virtual network, there's no proxy. It's just straight through.
So I haven't said much yet, Chris, and I think I just have to. I just have to say that I don't really understand how container networking works in the first place. So talking through these different types of networking isn't creating an image in my mind. I'm like, I get the words and they make sense and I know the rules that I could follow them, but I don't have a picture in my head of how this is all working in the first place. Because remember where we left off in the series on containers versus virtual machines is we got to a place where we had a real good understanding that a container is just a process that's running on the host operating system. And so already that's sort of like, well, wait, processes don't have their own network cards. So how is this happening where it's able to do networking? And bridged networking kind of makes sense. Like, okay, well, you're going to use the host network interface and you're just going to be on a port inside behind it, right? Like you're just like any other application. You're going to bind to a port. Yeah, I'm going to bind to port 7775. Okay, that makes sense to me. That's how networking works. Applications bind to ports, so I can do that. But once we get outside of that world, and we're not in that, my favorite category, which is none, then I'm a little confused.
Mm-hmm. Yeah, so maybe this is a good time to talk about bridge network mode, because this might shed some light onto that.
Okay.
So bridge, again, this is basically the default networking mode for just running Docker in general, and it's also the default mode when you run your containers in ECS. And so what bridge does is it utilizes, so Docker has a built-in virtual network service, and that runs inside each container is now using that. So think of it as a proxy. It's a network that's set up by the Docker daemon itself, right? That means that you're creating this, for lack of a better term, it's the Docker network. And so containers on that instance, they're all connected to each other through this bridge network.
But in order for me to understand that, I have to go a little bit deeper. I have to have a network interface, and it has to have, it has to conform to all of the layers of networking. Like it's got to have a hardware address, and it's got to have a, IP address, and all those things that I've learned about I can't remember the name of it, but that layer diagram. It's got each machine in that network has to have all those layers in the diagram for the networking to work. So I guess I don't understand. Like, are we creating a virtual piece of hardware? Is Docker creating virtual hardware for each? And if so, how does that work? Like, I need a little more groundwork, a little more foundation.
Well, so that, we're not going to go there because it gets really deep and technical with things like IP table. But you can kind of think of it as like it's routing, right? And so it's creating networks, it's creating routes, and it has route tables that kind of indicates like, okay, if this is on the Docker network, these are the IP addresses, right? The virtual IP addresses, and these are how you can go from this point to that point. There's that networking world, and then you have the world of everything that's outside that to go to access the outside world. Mm-hmm. And how do you get from the local Docker network out to the internet or any other machine, off that machine, right? And so those are the two networking scopes for our containers. On the actual host, containers can talk to each other over that virtual Docker network. When they need to talk outside of it, they're going to go through that virtual Docker network to the actual NIC, right on the host. Mm-hmm. And then now they can go out. And so think of it as a middleman, as a proxy, where Docker is kind of setting up these networks, and it's using things like IP tables and routing to create that virtual Docker network, and then also know when should it go out through the NIC and out to the open world.
Okay.
Right. So, and what this does, right? It's like, again, it's you're setting up. You can think of it as it's like private subnets, right? You're creating you're creating these virtual subnets for your containers, and so this is how inside those virtual subnets they're on whatever ports they want to be. But when they have to go out to the outside world, that's when now we have to do the port mapping. And that's what Docker is helping to manage, right? It's helping to manage on the host, I'm listening to port 8080, but I know now that that's going to go to this particular container, and it wants it on port 80, right? And to do that mapping between it. Mm-hmm. And so that's what bridge networking gives us, right? It gives us that ability. So now we can have multiple containers all listening on port 80 on their container network, and it's not going to conflict with the actual host network, right? Because there's going to be different mappings there. So it's outside the containers, they have to be listening on unique addresses, but inside them, they can be duplicated, right? So it makes it much easier to develop our code, right? We don't have to keep track of the mappings when we're writing code or configuring our applications, right? It's really only at deploy time that we have to worry about it.
Okay, so I can just swallow that, I guess. I can be all right with the fact that Docker is creating this sort of virtual network for me, and inside the virtual network, the containers have their own IP addresses, and the applications are bound to ports on those IP addresses. And that internal subnet, if you will, of Docker containers is not addressable to the outside world. And that if you want to get out to the outside world, you have to go through this bridge that you're talking about. Okay, right. I can follow that.
Right. Yeah. So our containers, they're sharing all the networking properties of the primary NIC, the network interface card, or like in the case of AWS, it's the ENI, the Elastic Network Interface. So they're all sharing that same IP address, right? And then all the rules that go along with it, firewall rules, IP addressing, everything. And then Docker is providing that translation between it. And so if something wants to address a container from the outside world, they're addressing it not just by IP address, but by the combination of IP address and port.
Mm-hmm. Okay.
So that's bridge. And so, so what are some of the disadvantages or limitations? One is you can't address these containers with the IP address allocated by Docker, right? So that kind of makes sense, right? Like we said, that this is the container network, the Docker network, with this different private subnet, if you will, right?
Mm-hmm.
Coming from a pool of locally scoped addresses. Like no one else outside of that container network knows about that. So you can't use those.
Mm-hmm.
Like so we said, you have to use the IP address of the host plus the port that container is being mapped to.
Mm-hmm.
And then the other disadvantage here is that you just can't enforce finely grained network ACLs, firewall rules on a per container basis, right? You can only do it at the instance level.
Mm-hmm. Okay.
And that's kind of pretty big limitation.
And I would need to know an example of like a rule that you would want to do that you're like, I can't because I'm using bridged networking. I need a use case. Can you come up with a use case?
Imagine you had, a bunch of services, and one of them was just really like, this is your like, it's like a really sensitive app. It's the admin app that maybe has access to like maybe financial data or something like that, right?
I was thinking about the Uber app, the one that let admins see where everybody is.
Yeah, sure. Yeah. So that one, right? And so but you have like you just want to have a cluster of EC2s, and you want to run it as an ECS service. And so it's going to get scheduled on one of these instances, right? You would like to lock that down and say, you know what? I only want traffic from this particular other network, or this particular, maybe even this just particular IP address, or from this particular subnet can only access that particular app, right?
Mm-hmm.
I want to lock it down, right? So it's not just, I don't want to use just straight user auth and authorization. I also want to use some networking rules as well to really lock it down. And so with bridge networking, you just can't do that. The only way you could do it is you'd have to create multiple clusters, right?
Right,
So
and then you could have cluster-to-cluster networking nightmares.
Mm-hmm. Yeah.
Okay, cool.
So this is something you can't do with bridge. So now we're going to talk about the fourth one, AWS VPC mode, right? And so again, we kind of started talking about this last week with because of Fargate, because Fargate requires this networking mode. You can't run Fargate tasks with any other networking mode other than AWS VPC. And so what happens here is that the network interface card is being created on a per task basis instead of on a per instance basis.
Right.
And so keep in mind AWS VPC mode, which is also known as task networking. You can use this both in the EC2 launch type as well as the Fargate launch type. So it's not specific. It's not only available with Fargate, it's also with EC2. It's just keep in mind with Fargate, it's required. You have no other option versus with the EC2 launch type, you have all four of these options available to you.
Okay.
So with AWS VPC mode, each task gets its own ENI and consequently its own IP address. It's kind of nice where you can have multiple applications now, including multiple copies of the same app, can all run on the same port number without any conflict, right? Because they're separate IP.
Yeah, it's super fascinating because it's literally a feature of virtual machines that makes this possible and not a feature of containers, right? Since every task is running in its own virtual machine, its own Firecracker virtual machine, that's how this becomes even possible. Without that, this stays impossible.
Keep in mind, we can do this with the EC2 launch type as well, which I don't think that...
Oh.
Right? I mean, so that's definitely not Firecracker. for sure.
Or is it? I guess not.
No, it's not, right? These are just EC2 instances.
So then how, that doesn't make sense. Like man, I just shot myself in the foot, but I totally get how you can put a network interface onto a Firecracker instance. I get that because like the whole series we did on virtual machines and how they virtualize everything makes it very obvious how you would virtualize a network interface. But the whole thing we also talked about during that series about how a container is just a process makes me really confused about how all of a sudden my container's got its own network interface.
Mm-hmm. Which, I mean, I think it's a bit orthogonal, right? Because it's like you can imagine having a machine and you can insert multiple NIC cards on it, right? And you can just, it's up to your code, right? Which one does it want to talk to? Do I want to use NIC 1 or NIC 2? Right. And so this is the equivalent of just on that instance, you're just
slapping more network
slapping another NIC card in there, right? And saying, okay, task, you get to this is yours. You get to use it, right?
Sweet, dude. That's such a like a aha moment for me. Thank you.
Mm-hmm. Cool. So some other things to keep in mind. So of these host and AWS VPC network modes, they're going to give you the best networking performance, right? Because there's no virtualization, there's no proxy, there's no middleman. So Bridge is going to be the one. Well, I guess none's the fastest, right? But,
yes, it's so fast.
Other than that, I mean, so Bridge is proxied, so you're going to have some performance impacts there. Host and AWS VPC, you're going straight through the NIC, right, with no intermediary. So it's going to give you the best networking performance. There's just no virtualized network stack that you're dealing with there. And the exposed container ports that you have, as we talked about, if you're using the host networking, it's attached to the corresponding host port. And if you're using AWS VPC, then it's going to be mapped to the ENI interface port for that particular task, right? So just the thing to keep in mind here, host and AWS VPC, you're going to get better network performance than you are going to be with Bridge. So it sounds like, hey, AWS VPC mode, this is great.
It doesn't like the way to go, except for the thing you were just saying was like, oh, now all of a sudden I have a bunch of tasks that are kind of on the network. A lot more surface area to like be aware of.
There is, I guess, with great power comes, great responsibility.
Yes, right? Tell me more, Spidey.
Yes. So on one hand, doing this task networking, having our own attached ENI, like this is going to simplify. One of the things, it does simplify container networking quite a bit, right? So remember we talked about there's two different, we can think of container networking in two different modes, right? One is like on the container network, and then the other one is over the outside the machine, right? Out over the, just everything outside the machine, right? Whether it be over the internet or other downstream services or whatever it may be, right? Mm-hmm. If we're talking to, we want to talk to the container network, it's really easy because they all share a network namespace and you can communicate with them over localhost. Now, this is at the task level, right? So this is for the situation like if you had a task with 3 containers defined in it, inside that task definition, right? Whatever your containers ports are listening to, those have to be unique, right? Because they're all running on the same NIC, and so they have to be on distinct IP addresses.
Okay, that makes sense.
But because they're all sharing the same NIC, they're basically, this is all local host, right? For all those containers. So for all those 3 containers, they can all refer to each other by just localhost or 127.0.0.1, and then whatever port number they're on. So it makes it pretty straightforward and easy for them to all talk to each other, right? You don't have to set up like, your own custom namespaces or DNS or anything like that, right? You can so it makes it very easy for containers within a task to talk to each other.
Right.
Let's see, some other nice things with task networking. Again, it's because you have this dedicated ENI to your task that lights up things like now we can do like VPC flow logs on a per task basis. So we can see exactly the traffic at the task level. And that's going to help us perhaps maybe, troubleshoot problems a lot easier than it would be if we were going off, using bridge networking where we had 10 different services all sharing the same ENI.
So what kind of problem would you troubleshoot with a VPC flow log?
This like if you have like maybe it's a security group problem where you just can't, a particular port's not open and you don't understand why is this thing timing out? Flow logs might be able to show you there what's going on, because you're going to see deny actions in those flow logs as well. Kind of like the kind of basic networking, like, hey, do I have connectivity to this? What are, is it a firewall that's blocking it? Those kinds of things. So they're not, full disclosure, VPC flow logs is not a fun place to be. Mm-hmm. If you've ever looked, they're literally just, it's basically all the header information with your packets, right? So it's not you can't actually look at the packets. You're just going to see things like, okay, what was the source? What was the destination? What was it trying to do? And what was the result?
No, but I can kind of see what you're saying. It's like, if you have task level networking, then VPC flow logs might actually tell you something useful. Whereas if you don't, then you might not even bother ever cracking those things open. Like, why bother? Yep. It's just a bunch of noise.
And then correspondingly, the other thing is that we have better security now, right? Because we can do much more fine-grained security. So we now can have different security groups for each one of our tasks. And so this lights up the scenario we talked about before, where it's like, if you want to be able to lock down a particular task to, really restrict the ingress traffic to it, you have a security group just for that ENI that's associated to that task, and you can lock it down as much as you want. And so we have now that fine-grained security control over it. So pretty big benefit.
All right.
So the limitations, right? Like, where's the downside to this? And so the downside is just, it's all about networking density, right? Like, you can only attach a certain number of ENIs to an instance.
Okay. Yeah, that was one thing that we were just talking about. That was my aha moment. Like, oh, how are all these containers getting their own ENI? And you were like, you just slap them on the instances. Oh, got it.
In the Fargate world, like, we don't have this problem, right? Because it's AWS's problem. They have to go figure out how to do it. Mm-hmm. So we don't have to worry about it there. If we are in the EC2 launch group world, we do have to worry about it. So by default, it's going to depend on the type of instance you're running, how many ENIs can be attached to it. It's a fairly small number of ENIs that can be attached to an instance. So for example, a C5 large EC2, you can have up to 3 ENIs attached to it. Okay. So that's one is for the primary. So that EC2 has to have its primary ENI, which leaves 2 ENIs for task networking. So that means, on a standard C5 large EC2, you can only run 2 tasks using AWS VPC mode.
I'm sitting here in my mind. This is what's going on in my head. I'm like, ooh, so you can make a task that all it does is a single XOR. And then you could say that you want 100,000 of them and you want to do task, like task level networking, and then be like, all right, AWS, figure out how to deal with this. and like, now they've got to give out so many IP addresses for just doing your little XORs. Mm-hmm. Like, a task that basically does nothing. Mm-hmm. That would be a hard problem.
Mm-hmm. Yeah. And so, as Fargate, that's what they have to do, right?
Yeah.
So like every Fargate task, they are allocated an ENI for that and wiring it all up. So for however many tasks you run, that's how many ENIs they're created for you. And keep in mind, those ENIs are being created inside your VPC on your subnets, and they are taking up IP addresses of your address space, right? So be careful. If you go spin up too many of them, you'll find out, okay, I'm out of, I don't have any more IP addresses.
Okay.
And they're all gone, right? So something to keep in mind there.
Wow.
So yeah, this is a little bit of a bummer, right? This ENI density type thing, it doesn't make it, sounds like it's not very useful with ECS, right? Because we're typically running, 10 task, 20 task on an EC2. Mm-hmm. So how does that work? So AWS has addressed this. This is kind of one of the recent advancements over the last year or so. And that is, you can now increase your ENI density through something called trunking. So VPC trunking, it's a networking feature that they offer that basically increases the number of ENIs that you can attach to your EC2s. The way they do this, it's multiplexing data over a shared communication link. Mm-hmm. What you end up having is for each one of your instances that has trunking enabled, you're going to have the primary ENI, and then you'll have a trunk ENI. And the trunk ENI is that multiplexer. And so, you're now attaching your task ENIs. They're all going through that trunk. And so with this particular model, you get 5x to 17x more ENIs per instance, right? So to go back to our example of the C5 large, it's with trunking enabled, you can now go from 3 to 12 ENIs. So that means that you have one ENI is dedicated for the primary, one's dedicated for the trunk, and that leaves us now 10 for task networking. So that means instead of just being able to run 2 tasks on a C5 large, we can actually run 10 tasks running a C5 large, which is quite a bit better. So this is something you have to opt into. Okay, yeah. I imagine it costs more or whatever. Yeah, well, I mean, you're going to be allocating additional ENIs, and you just pay by the ENI. Yeah. Okay. So yeah. Huh, that's interesting. You can opt into this at the account level or the role, and it's a specific setting. So inside ECS, they make it pretty easy to do this. It's actually in the settings section of the console for ECS where you can go in there and say, yes, I want to opt into VPC trunking. Right. And then when you do that, now that will be enabled. And so now whenever you spin up an instance, it will allocate the trunk ENI, and you'll now be able to attach more ENIs to it. So now we have 2 highly related things that I'm allowing for us to just be squishy on, that we have to go talk about in a future episode. And one is really how that container bridge networking works, how that Docker network actually works. And the other is how this VPC trunking works. Because while I can completely understand throwing network interfaces at a computer, this whole VPC trunking thing is just magic. Oh yeah, it's click here for magic. Someday I want to know what that magic, how it actually works. Because at the end of the day, it's going to be a little bit of code, and it's not going to be, all this magic stuff that seems so complicated generally ends up being oh yeah, that makes sense once you figure it out. Mm-hmm. Yeah. Yeah. And I think, I guess, a good way to think of it is it's just software, right? And so it's at the hardware level, the machine it supports a certain number, a density. And so as far as the machine knows, there's just 2 ENIs, 2 network cards with it, right? And so now you're using software to kind of add these additional ones, and then they're all going to share and go through that ENI that's been assigned to them, right? But you're using software to build on top of that without changing the operating system or the hardware, of the actual system itself. Yeah, right? Yeah. I just want to know more about how that actually works at some point. Someday we'll get there. Yeah.
Just a sec. There's something important you need to do. You must have noticed that Mobycast is ad-free, but Chris and Jon need your help to make this work for everyone. Please help the Mobycast team by giving us 5 stars on iTunes, writing positive reviews, and telling your colleagues, friends, neighbors, children, and pets about the show. Go ahead and do it now. Great. I promise not to ask you to do that again.
Cool. All right. Well, we've gotten through now that we talked about identity access management. We've talked about container networking. So I think we're now ready to talk about, okay, we got a task and we want to convert it over from EC2 launch type to Fargate. What do we need to do? Right. So this wouldn't be all that common for anybody that's kind of new to this. It would only be people that, were oh yeah, I'm all in on EC2, ECS stuff. Oh, look at Fargate. It's all of a sudden more reasonably priced. Maybe I should move over. Right. Which is probably going to be the bulk of folks, right? I mean, ECS has been out there now for since 2015? Mm-hmm. And, Fargate really didn't kind of become viable until early 2018. As we talked about when it first launched, it was, quite a bit more expensive and whatnot, and prices coming down. So, I think, in general, you got a lot of people out there that are running using EC2 launch type. Okay. So it makes sense to go look at hey, does it make, should we switch over to it? And, is it cost effective?
And is it a button click? Like, how hard is it going to be?
Exactly, right? Like, what are the steps? Like, do I have to re-architect, right? Is it going to be a complete app rewrite? Or is it just, is it a couple checkboxes? So that's what we're going to talk about now. It's just like, well, what do we have to do differently? So, just imagine we have an existing service. I actually went through this process for my own personal blog site. So I basically have a Node.js app that is my blog app, right? It's
Should I give you a hard time about spending more time architecting and building your blog than blogging?
That's the reason why we all have blogs, right? It's to mess around with the blog software, the platform, right. And give us excuses for not actually producing content. So yeah, it's kind of shameful. I think my last post was about a year ago. Yeah, it's on the to-do list, right? I mean, there's tons of things to write about, right? But it's always more fun to play with code and deploys and
for sure. And we've got Mobycast, and here's your sort of blog right here.
Yes,
you're listening to it right now.
Yeah, indeed. So I have this existing app. It's fronted by an ALB, and I've got obviously a DNS set up with Route 53 to do that. So the ALBs are listening on ports 80 and 443, and then those are now forwarding them on to my ECS task, right? Through the listeners that I set up and the rules. And so now I want to move that over to Fargate. What needs to happen? So one is, okay, we got to do some stuff with roles. And so now that I'm going to Fargate, there's going to be two additional roles that are going to come into play. One is the Amazon ECS service linked role. And that is what gives ECS permission to attach ENIs to the instance. Just know that this exists and it has to be there. We don't have to do anything. AWS is going to automatically create this for us, right? And it's just going to work. But just know behind the scenes, that's what's happening. And then likewise, we're also going to need now a task execution IAM role, like what we talked about last time. And that's for giving access so that the task, that task management type functionality. So pulling images from ECR, or pushing logs to CloudWatch. So that role needs to be set up. And again, it's going to be created automatically for us by ECS if it doesn't exist when we go through this process.
And that's only if you're using the console, right? Like if you're trying to do this with CloudFormation, you'd have to be aware of this and go make a role and refer to it from CloudFormation. That's
a good question. So I suspect you're right that you would have to do that yourself. That's part of one of the advantages of going through the consoles is doing some of this for you as a wizard, if you will. But if you go through CloudFormation, then you're going to be much more explicit and specify like, yep, I need to go create this role.
That's a good point. I just want to quickly divert on that. I think a lot of folks are kind of like, I'm not really using AWS if I'm not doing infrastructure as what's the word? Like
infrastructure as code.
As code, yes, that's what I'm looking for. And you don't have to, right? If you know you're just going to build a system that's going to have like a couple environments, maybe a dev stage and production, and you know that that's what it's going to be for a couple of years, you can save yourself a lot of time by not going down the CloudFormation path. It really is a time-consuming killer. And like, if you're not spinning up and tearing down environments willy-nilly, like you save yourself that 125 hours and use it on your features. Anyway, just a little side note.
Yeah, I mean, it's definitely one of those things where it boils down to just how many people are involved and, just how much flexibility you want and how much of a down payment how much of an investment you want to make in doing that. Right. So learning how to do infrastructure as code, whatever platform you use, whether it be CloudFormation or CDK or Terraform, there's a big learning curve there, and it's an ongoing learning curve as well.
Yeah.
So it's pretty sophisticated, and it's going to require a lot of time and resources. And think of it as a whole nother software project for all intents and purposes. I think that's
the best point. Think of it as another additional software project as opposed to like, oh yeah, it's just the edges of the main thing that I'm working on. Yeah.
Yeah. Indeed. Cool. So we have those two roles. Again, they're going to be created for us automatically. So just be aware of them. And then the other thing we're going to do now is we're going to create a task-based IAM role for our task. So me personally, I didn't have to do this before because I was running on the EC2 launch type. and I was being lazy, and I was just using the ECS instance role, right? So I was sharing that one role for all of my containers. Turns out the only thing running on my EC2 is just this one service, so it's not that big of a deal. But that's what I was sharing. I was reusing that role for any kind of programmatic access that my app needs. And so my app does need AWS access to things like S3 and KMS. And when we run in Fargate, we no longer have an ECS instance role, right? Because we're not running it on our instance anymore. So that just doesn't exist. So I have to create this task-based IAM. And it's pretty straightforward, pretty easy. So first, I need to go create an IAM policy that's going to give the minimal privileges needed by my task. And remember, we talked about there's two categories of policies. There's the AWS managed, and so that's like that catalog of just a bunch of different pre-made policies for various different services, giving things like, oh, I want full S3 access, or I want read-only S3 access. For all the different various. So there's like over 500 of these managed AWS policies, and chances are one of those is one or more of those is going to fit the bill for you.
Yep.
Or you can have a customer managed policy, right? And so for me, I'm going to go with a customer managed policy because I need KMS, and there's no KMS managed policy that kind of fits the bill here for this. So what I'm going to do is I just go to IAM and policies. I'm going to go ahead and click on the create policy button there. And then I'm just going to slap in my JSON for my policy, right? My policy is going to be really straightforward. So it's just going to be, it's going to be an allow effect. There's going to be two actions that it's going to allow. One's going to be S3 get object. And so that's so that I can go read something from a bucket, a file from a bucket. And then the other action I'm going to allow is KMS decrypt.
Okay.
And then I'm going to specify the resources that those things can act upon. And so then
that's your bucket and your KMS.
Right. Yeah.
Master.
So I'm going to list the ARN for my S3 bucket that this task is going to talk to. And then I'm also going to list the ARN for the KMS master key to do the decrypt operations. Because really so I have some secrets for this particular app that are KMS encrypted and store as a JSON document and store it in an S3, right? So it needs the S3 access to go read that file, and then it needs KMS to decrypt it.
Cool.
So it can read those credentials.
Cool.
So I've got my policy now, and so there's a custom policy I've created, and then now I have to go and create a role. And so I'll go back to IAM, create a new role. This time I'm going to base it on you're going to get some options there, and one of them is the first one actually is going to be a service role, and so I'm going to base this on the ECS task service role. By doing that, it basically is just setting up the trust relationship that will allow ECS to use that security token service to assume the role and perform the actions on the behalf, right? So that's what you're doing by choosing that service role.
Yeah, that's what we talked about last episode a lot. Is like the code's like, okay, I need to get a role that's it's got to have this like name. Oh, here it is. Here's the one.
Yeah. So then once I choose that, so I'm going to choose ECS as the service. I'm going to choose the Elastic Container Service task as my use case. Once I do that, I can now just attach the IAM policy that I created before and save. So now I have my role. So now I have my task-based IAM role. It's locked down. It can only do those two things: the S3 get object and the KMS decrypt. And now I'm ready to move on. So the next step is to go and build our task definition file, make the changes to it. Yeah,
because you already have a task definition, right? A task definition file. You just need to change it.
Right. Yep. And so pretty straightforward here, not much work to do. So one is there's a required compatibility section. In there, I'm just going to specify Fargate. And so that's going to say that this is Fargate eligible, this task.
Okay.
The other very important thing I have to do is I have to switch my network mode specifically to AWS VPC mode. So that's going to be at the task level, a parameter there. I'm now going to change my CPU memory limits to be defined at the task level again and make sure they're not at the container level. And we talked about that last week as well, right? But it's just saying like the CPU memory limits are being allocated at the task, not necessarily at the container. Although again, usually we have one container per task.
Right.
And so it's usually a one-to-one mapping.
Right. Also, just a quick interruption. Hey, Gus. Just want to say hey to Gus. Everybody knows about Gus. He's our third member.
He's not even close by either. But something has got him excited.
Yeah.
He's let out a bark or two.
He's a good dog.
So two other very important things that we're going to do in our task definition are specify these roles that we talked about. So one is we need to specify the task execution IAM role. So that's that execution role ARN. And again, remember, that's the one that allows the task to pull images, allows us to pull images from ECR and send logs to CloudWatch. Mm-hmm. So we're going to specify that in the task definition file. And then we're also going to specify that task-based IAM role that we just created, right? So say like, hey, this is the task-based IAM role that this task is going to use when it gets instantiated. So go get the ARN for that and put that here in the task definition file.
Cool.
And really the only other change we need to do here is we just need to make sure we can, in our networking for our container, just make sure that we're just specifying container port. We're not going to be specifying host port anymore. Although I don't think you'll get an error if you do specify host port, it'll just ignore it.
Okay.
So now we have a role set up, we have our task definition, so now it's time to go create a service. So we're going to go into the console, go to ECS. We're going to choose the cluster we want to launch this into. We could either create a new cluster or we could use an existing one. For me, I already had an existing cluster that was based on the EC2 Linux plus networking mode, right? So I have a cluster of EC2 hosts. So I'm just going to use that because I can launch Fargates into that Fargate task into that cluster. If I wanted to, I'd go create a new one, like a networking only cluster. I could have used that as well. Just both are equally valid and fine. Now that I've chosen my cluster, I'm now going to define everything about the service that I need to. So one of the important things is now I'm going to specify networking, right? And this is new, like in general, like with the EC2 launch type and using bridge networking, I don't need to specify this. But with the Fargate task, because it's AWS VPC mode, now I have to specify all the networking with it. So that means I have to specify what VPC it should use.
Okay.
Also all the subnets that it should use.
Okay.
And then I also need to specifically declare what the security group is that this is going to use.
If you give it more than one subnet, is it just like, I'll just spray them into the subnets, the tasks?
Yeah, it's going to spread them across.
Okay.
Them. Yeah.
And also a silly question, but I assume as you're doing all this, your blog is up and running on the existing cluster. Like you never took it down. It's just running. It's happy.
Correct.
Okay.
Yeah. And then because I'm running in public subnets, I'm also going to want to auto assign a public IP. And so that's just a little checkbox here I can check off as I go through. So now these ENIs will also have a public IP address associated with them that will allow them to talk to the outside world.
Okay.
So now that I've specified my networking, I can now go ahead and attach to an existing my load balancer. And so, like I said, I already have an existing application load balancer. And so I'm just going to use that for this particular service and just piggyback on it.
Right. And
so I just specify my production listener, my port protocol. So I may be listening on port 443, right? Because I want it's all TLS traffic. And then I specify my target group. So I'm going to create a new target group. When you specify the target group, you're also going to be specifying the target type. The target groups have 3 types that they allow. Those types are instance, which is for basically bridge mode type networking, or host. You have IP, and that's what is used by AWS VPC mode. And then you can also specify targets of Lambda functions. So for us, because we're Fargate, that requires AWS VPC. That means that our target type is going to be IP.
Okay. That'll
actually be set up for us. There's really nothing, we're not even able to change it. It's just going to be, we'll see that's what we're basically forced to go with. And then after that, we can specify a path pattern for our listeners. So to tell our application load balancer, giving input traffic, when should it route to this target group versus some other target group. So now we have our service that's created, tasks are being launched. Now for me, what I had to do is I also had to do now some security group modifications. So I had two other security groups that came into play here. One was a security group for my ALB, and for kind of a better security posture. I have it locked down for the outbound traffic, because I only want the ALB to talk to basically my ECS services. Really shouldn't be making a request anywhere else, right? So I had to add a new rule in there to say allow outbound traffic on port 80 to the ENI, the security group for the ENI that we just created for the Fargate service.
I lost you there a little bit. Like, you were talking about outbound traffic. Who's talking? Like, outbound traffic to me means, maybe the ECS tasks are trying to talk out to the network. And I'm not sure what they would be doing in terms of a blog, what? Yeah.
Yeah. So inbound and outbound, right? And so for your load balance, so the load balancer has a security group. So inbound is like, okay, from the open internet.
Yep.
What are the rules for allowing that in, right? So I have listeners for things like port 80 and 443 to allow everyone, right? 0.0.0.0. The whole world can talk to it. Then you have outbound. And so that is, what are the connections that the load balancer can make when it's making calls itself out somewhere else?
Okay, got it.
Right? So I'm going to lock it down and say, load balancer, I only want you to be able to talk to my ECS services. So I'm not going to make it 0.0.0.0. Instead, I'm going to have a rule set up that says, if it's port 80 that it's talking to my Fargate service on, I'm going to create a rule that allows outbound port 80, but the destination is going to be the security group for that ENI.
Okay,
right?
Got it.
So it's just locking it down.
Mm-hmm, mm-hmm. Yeah, makes sense.
And then likewise, I had a similar rule to set up on my RDS instance. So my RDS instance, I'm only allowing inbound access from the security groups of my ECS services.
Okay.
And so now I specified, I added an inbound rule for my RDS security group to allow traffic from the security group of the ENI as well.
Okay.
Right. So that now allows my task to now go attach and make calls and to my Postgres database.
Mm-hmm. Okay, that makes sense.
Yeah. And so that's basically it, right? What I did, I kept my site. I didn't touch my main site. This is spinning up a new instance of my site, and now I have this running under a different TLD, right? So it's beta.chrisick.com instead of blog.chrisick.com or whatever.
Okay.
So that way I could test it and say, okay, yeah, this is or I could have just switched it over too, right? I could have just changed DNS, or I could have, since I was using the same ALB, I could change my routing rules to just say route to the Fargate task instead of route to both target groups.
Yep.
So it's whatever you want. I knew I was just using this as an exercise. I wasn't going to stay with Fargate. I just created a separate thing for it, and really easy to do with things like host-based routing on my ALB, and really quickly add a new Route 53 record.
You're so funny. That's so funny. I knew I wasn't going to stay with Fargate. I'm a single speed bike rider.
Yeah.
You took all the effort to switch over to Fargate, but you're like, no, I still need to be able to touch those machines.
Yeah, indeed.
All right.
And it just really quickly just to follow. So one other thing would be, logs. And what do we do there? So we talked about, Fargate, it only supports the AWS logs driver. It also supports Splunk. So if you're using Splunk, you're in business. Otherwise, it's CloudWatch logs. And so that means that we have some extra work now if we want to use a third-party service like Sumo or Loggly or whatever it may be, right? One of the things I had to do is I had to change my code I was redirecting standard out, standard error to a file so that I could easily see it on the host itself. Mm-hmm. And so I had to change that for this to not trap that anymore. Mm-hmm. So let just standard out and standard error just be emitted so that Docker would grab it through the AWS logs driver, and then it would be shipped over to CloudWatch. So once that happens, you now have your logs in CloudWatch, and then it's basically an exercise for the reader to go figure out how to get those CloudWatch logs into whatever other system you want to do. And there's many ways of doing that. It could be, you could have a Lambda function that subscribes to the CloudWatch log group that, as these logs are created, it sees that, it gets notified, it runs, and It can reformat and then send them over to wherever it needs to go. You can use things like Kinesis, and there's other techniques as well.
Please tell me that you didn't remember to do that at first, and that things weren't working, and you're like, "Where's my logs?" And then you flipped over your desk.
Yeah,
that's what Chris did. He flipped over his desk.
Yeah, yeah. That's how I roll. Yeah, pretty common. Anger management's pretty much an issue here. No, I mean, I knew what I was giving up. I mean, this is one of the reasons why Fargate has been, just one of those. I knew there was going to be work involved, just because of the logging thing.
Right.
I'm not a big fan of CloudWatch logs. It's getting better with CloudWatch Log Insights, but it's not Sumo. I love me some Sumo Logic. Sumo, if you're listening, sponsor.
Yep, there we go. Yeah.
We will give you some love. So that's been one of the things. I just know that there's going to be extra work there in order to get that integration that I need. So
cool. Well, how awesome. I think we got through it. We did it. ECS in a bag, 3 episodes, no problem. And I think you did a write-up a little while back where it was like, here's how to do an ECS installation with EC2. And you had it in like a, bullet point form, and I followed it and we did it with a client, and it was like, oh, that is so valuable. Those bullet points. Like, how much would somebody pay to just get their hands on this? And here it is for free in Mobycast.
Yes.
All right.
And hopefully even a little bit entertaining as well, right? So,
well, thanks very much. And I'm on vacation next week, but Mobycast will keep rolling. So, all
right.
I will talk to you in a couple weeks, Chris.
All right. Enjoy.
Bye.
Bye.
Nobody listens to podcast outros. Why are you still here? Oh, that's right. It's the outro song. Come talk to us at mobycast.fm or on Reddit at r/mobycast.